Now in this video what I'm going to do is I'm going to show you an ellipse problem extremely similar to the other video I did. Here's the concern that most students have. They say, Mr. Moya, graphing ellipses isn't too hard, but what if the numbers aren't perfect squares? Like in the last problem I gave you, used the same numerators, but I used 9 because the square root of 9 is 3, and I used 1 because the square root of 1 is 1. So easy numbers, but now I've got these numbers like 8 and 2. So how do we approach graphing this? Same method, same mentality, same steps. Where's your center? Your center is at 2, negative 1. Same place. 2, negative 1. Okay. That doesn't change at all whatsoever. You're asking yourself, well, how many do I move in the x? Well, the square root of 8 isn't a pretty number. This is a time where you actually don't want to simplify it by using a factor tree. What you want to do is you want to make an equivalency. Now, you can pull out your calculator, but the method I'm going to show you is if you didn't have a calculator. Here's what I know. I know the square root of 4 is 2. And I know the square root of 9 is 3. Sorry, I wrote those really small. Let me try that again. The square root of 4 and the square root of 9, 2 and 3. 8 happens to be in between here. So I should assume that my decimal is like 2.8 or 2.9. Now the reason I can think it's so high is because it's closer to 9, so it's definitely on the higher end. Now obviously this is an estimation. If you use your calculator and you get something way closer, well then good for you. But in a piece of graph paper, what that means is I'm going to go 2.8 over in the right, 1, 2, 2.8ish, 9ish right there, really close to 3, not 3. 1, 2, really close to 3, not really 3. So this is what you do when you have to graph problems that aren't perfect squares. Now the square root of 2. Again, the square root of 2 is how I'm going to move up and down in the y-axis because that's where it's located. I know the square root of 1 is 1. I knew the square root of 4 is 2. So as you can see, it's a lot closer to the 1 than it is to 4. Estimation, you'd say, Mr. Moya, it's like 1.25 or 1.3-ish. Good estimation. Closer to 1 than 2. So from here you're like 1.23-ish up. Not halfway, not close to 1. Same thing, jump 1, not halfway. So these types of equations are definitely estimations. So that's what I want you to really understand when you're graphing ellipses of this nature. It's that it's an estimated up and down mannerism. Still, once you graph those, you got an ellipse, life is good, and that's how you do it.